In this video, the learner will solve problems involving angles of elevation and angles of depression. So first we need to understand what those angles are, and those angles of elevation and depression are going to use what's called line of sight. So when we have someone looking at something, your eye's line of sight is what your eyeball is lining up with. These angles are always going to come from the horizon line to the line of sight. So if we have this guy, and then here's the horizon line, it's always horizontal. If he decides to look up in the air, that's an angle of elevation. So from the horizontal upward is an angle of elevation. Well, then we have this guy over here, and here's our horizon line. And he decides to look down at something. That's going to be an angle of depression. So notice they always come from the horizontal and either look up or look down. Now, once we understand these terms, we can actually draw diagrams to help us solve problems. So just a little practice here. Sven is on top of a building looking down at Anna. So here's Sven at point S, Anna's at point A. Which angle would be an angle of elevation from Anna to Sven? Well, from Anna to Sven, we have the horizontal and then looking upward. So from the horizontal looking upward is angle 1. So angle 1 would be considered an angle of elevation. Which angle would be an angle of depression from Sven to Anna? At point S, we have angles 3 and 4. We always look from the horizontal line, and we're looking for an angle of depression, so from the horizontal line downward would be angle 3. So angle 3 is our angle of depression. Angles 2 and 4 come from vertical lines to that line of sight, and so neither one of those are angles of elevation or angles of depression. All right, what we want to do here is we want to draw a diagram that depicts the problem and then use trig equations to solve it. So a person is standing 800 meters away from the base of the Chrysler building in New York. So here's my Chrysler building and a person standing 800 meters away. The angle of elevation to look up at the top of the tower is 21.8 degrees. So this person is looking up at the tower at an angle of 21.8 degrees. We want to know how tall the tower is to the nearest meter. Well, notice what we've set up here. We've set up a right triangle where we know one of the acute angles and we want to solve for one of the sides of that right triangle. So we know we can use sine, cosine, or tangent. The x is opposite from the 21.8. The 800 is adjacent. So we could use tangent of 21.8 degrees equals the opposite over adjacent. When we solve this trig equation, we get 800 times tan of 21.8 degrees, and we get approximately 320 meters. Our next problem, we have a ramp that is 120 feet long and rises vertically 15 feet. So the vertical rise here is 15. We want to find the angle of elevation of the ramp to the nearest degree. Well, from the horizontal, that angle of elevation will be between the ground and that 120 feet. So that x degrees is right here. Well, we notice again we've created a right triangle where we now want to solve for the angle. So we know we're going to have to use an inverse trig function to do that. So we have our angle x that's opposite from 15, and 120 is the hypotenuse. So using opposite and hypotenuse, we know we'll use sine. We take the inverse sine of both sides, and we know x degrees is going to equal the inverse sine of 15 over 200. So x is approximately 7 degrees. Our next example, from the top of a lighthouse, an observer notices a boat and finds the angle of depression to be 12 degrees. If the captain of the boat knows that the lighthouse is 200 feet tall, how far out to sea is the boat to the nearest tenth of a foot? We know the observer was inside the lighthouse, and so the horizon line we're going to use comes from the lighthouse. So we know our angle of depression is going to come from that horizontal. So our 12 degrees is here. But we want to use this right triangle here with the lighthouse tower being 200 feet tall. Well, notice we have two horizon lines, and those are going to be parallel. Therefore, we have a set of alternate interior angles that will be congruent. So notice that angle of depression here is actually congruent to the angle of elevation here. This will actually always be the case. I want to know how far out to sea the boat is to the nearest tenth of a foot. So I have this right triangle here, and I want to find x, how far the boat is out to sea. Well, I know 200 is opposite, x is adjacent, so I know I can use tangent. So tangent of 12 degrees equals 200 over x. We would multiply by x and then divide by tan of 12 degrees. So x is going to be equal to 200 divided by tan of 12 degrees. Therefore, the boat is approximately 940.9 feet out to sea.